will give high weight to this task and we will give low weight to this task, right? So from this artificial neural networks evolved. So I'll not go in detail about artificial neural network. So from artificial neural networks, little advanced one is convolution neural network. So sir, next slide. Convolution neural networks come to my session outline is simple convolution neural network explainability. How can we achieve? Okay, in convolution neural networks, if simple convolution neural network, if you work it for classification or some tasks, we will not publish any paper. So because a lot of work already done, okay, in this part. So what we have to do, we need to focus little depth, that is explainability or interpretability. Okay, how these convolution neural networks extracting data, which features it is extracting, that we can go through it. Next one, graph neural networks, little advanced and recent topics. Only top universities are working in this area. And now how these GNNs we use for drug. Okay. And the next one, how we can extract the features, how this GNN extract features to do particular task, how to extract those features. We are using explainability, we will extract those features quickly. And finally, I'll discuss conclusion and future direction. We will see. Now, convolution neural network, we know now before going to this deep learning and machine learning, AI, these terms we are familiar. So AI is big picture, like you take big circle. Inside that machine learning is a small circle. Inside that deep learning is small structure, one more small circle, right? So deep learning is subset or subpart of machine learning. Now question here comes, we have wonderful machine learning algorithms. Why we are going for deep learning? So there are three fundamental differences. I know so many other differences are there. The first fundamental difference is for machine learning, we need to extract features. So we need to extract features and we will give to machine learning algorithm. It will do it, maybe prediction or classification task. But that is hectic for us. Even some domains, research domains, if you take it natural language processing, if you take it signal processing, if you take it bioinformatics, DNA data, protein data, whatever it is, even domain experts unable to identify proper features. This is the problem with machine learning. Okay, if you will not extract proper features, what SAR used one word, if you feed wrong data, how much processing you do, how much machine learning wonderful algorithms if you use it, obviously it will fail finally, right? So we need to extract features. Nowadays we are becoming so smart and so lazy, we can say it, that laziness introduced new topic, we can say deep learning. We are not taking headache of feature extraction, we are throwing that headache to deep learning. You process it, you extract features, you only classify it, finally I need answer. In this case, and this is one fundamental difference between machine learning and deep learning. In machine learning, only it will do processing after giving features, but in deep learning, it will extract features. Two steps are there. Feature extraction is there and processing also there. Two things are there. Now, second difference, machine learning, nowadays real-time data is unstructured data. Huge data is producing. Day by day, we are producing by sitting here, we are producing data, right? So real-time data is huge nowadays. Every data is a big data. To process big data, our machine learning algorithms will not work. Why? Because machine learning algorithms work on static data. You got some data, on the data you extracted features and you performed. Suppose new data produced, again you have to start a training from the beginning. So deep learning, what it will do, already you trained model, on the top of it transfer learning concept is there, new data came, again we train, okay, with that new data only, no need to do training from scratch. Okay, this is the advantage. Second advantage, one is real-time data is unstructured and big data, it will handle, deep learning will handle that big data. And another thing is feature extraction, it will do it, feature extraction it will do it, and dynamic data it will handle it. These are the major differences between machine learning and deep learning. That's why we are going for deep learning. So now simple, we will use this training and testing, right? What is the meaning of training in artificial neural network? updating the weights. Simple training means updating the weights. Now, if you come to convolution neural network, what is the meaning of training? Updating the kernels. Simple kernels, we will update it. Okay. Now, machine learning, so deep learning part. So, just go to CNN. Yeah, this. Here, this is the convolution operation, convolutional neural network, convolution operation. So it is not a big, that word is different, but operation is very simple. Sum of products only we will do it. Convolution means. So we will take kernels initially, random values we will initialize. By the training time, due to back propagation, we can update the kernel values. We can update the kernel values. Two parts are there. One is training, like updating the kernel values. So are extracting the features, important features, first part, and classification or prediction, second part. Okay. Now we will update the kernels. So finally, after training, which we have kernels, those are trained, okay, kernels. Okay. Next, on test data, the same kernels will use it and will do classification and prediction part. Classification and prediction. Here the question will come, whatever the training we did, okay, it extracted features and kept in kernels. Now we should use those kernels and we will identify which type of features this CNN is extracted. CNN is extracted. That's what we can say explainability or interpretability, right? So now next. So I'll not discuss this convolution, padding, stripes. These are the topics in simple topics in CNN. Just go. Yeah. Next. Step. Pooling is like feature reduction in machine learning. Important features only we will pick it, and unimportant features we will skip it. Same way like pooling, it will perform. So now come to here, this part. So this part where I'll explain explainability. One is CNN for divergent signal prediction. So in biological, DNA sequence is there. DNA contains 4 characters. Computer science point of view, I'm talking. 4 characters, ACGT, 4 characters are there. So DNA sequence is combination of these 4 characters only. ACGGGG like this. How can we process it? If DNA sequence is given, how to extract the features? Even biologists can't extract the proper features. What are the features in string? Pattern only. So difficult to identify important patterns. That's why I'm putting to CNN or RNN deep learning. It will only extract important patterns to classify it. This, what is this signals means? In DNA sequence, it look like ACGT characters, but in between different signals it contains. DNA converts into RNA. At least in COVID time, you listen this RNA word, RNA, DNA, all these words. So it will convert into DNA to RNA, and RNA to protein, it will convert it. In RNA, some regions only convert into protein, other regions it will not convert into protein. So the regions which are convert into protein, we can call it as exons or coding regions, and another non-coding regions. Exon intron region is there, intron exon region is there. If you identify wrong regions, it will generate wrong protein and it will work opposite what it wants to do, right? This is the problem. That's why we need to identify simple signals. Okay, whether signal is there or not. Simple problem. What is the problem? Simple, whether in this DNA sequence signal is there or not. If it is a signal is there, it will classify yes, true signal, false signal, something like that. There are 2 types of signals. One is exon intron boundary, donor sites we can call. Intron exon boundary we can call acceptor site. So this is a binary classification problem. I simply train binary classification problem. After that, how can we extract important features through explainability? That we will see. So here, if you see in this diagram, first part is ACGT, DNA, then UGCA, that is RNA, pre-mRNA. So again, I'll not go much biological. There is a process called splicing in eukaryotes like humans. So there it will identify exon intron boundary. I represented like different colors. Green is green. So that between those boxes, whatever the introns are there, those are not useful. Finally, we will combine only exon regions. After the translation process takes place and protein will generate. Simple idea. Cancer, if you see nowadays we are listening, almost every village one person is dying due to cancer. Why cancer is happening? So Suppose you take one simple cell in our hand, every some duration cell will generate, new cell will generate. Suppose due to wrong proteins, the protein task is, particular protein task is, it needs to generate a new cell, okay, after particular duration, after 10 days or after 20 days, one cell, it needs to generate it. Suppose after 1 hour, it will generate a cell, what will happen? Just imagine, in our cheek, one cell needs to generate for every 10 days once, okay. Suppose if every 1 hour, one cell is generating due to wrong protein, what will happen? Oh, it will grow, right? Okay, bulge, right? So same way cancers, even though if you remove cancer tumors, what is happening? New tumor is generating. So due to wrong proteins. Proteins will do some task, even though if you sleep, okay, if you are very lazy fellow also, your body system will work perfectly, right? Your heart will work, your brain will work, everything will work perfectly. So human system is designed like that. In that process, why we are not getting proper treatments for this cancers is, we are unable to control that mechanism, working mechanism. Automatically cell is growing, okay, cell is growing, so we are unable to control that, okay. So what is the problem with wrong proteins is, if you generate wrong proteins, obviously it will work in wrong way. Like COVID, you take it, what COVID did, COVID changed the actual DNA due to that wrong proteins generated. It works anti to antibodies. Whatever the antibodies are there in our body, which will protect from diseases, this COVID thing, COVID virus worked opposite to that. Okay, this is the theory according to the literature. Yes, so that is the problem. Now come back here, next slide. So it is important to identify those signals properly, that boundaries properly, otherwise wrong proteins will generate. Yeah, now these exon intron boundaries, I said donor sites, and intron exon boundaries we can say acceptor site. Now come to CNN. What is the advantage of CNN? CNN works for grid-like structures, properly grid-like structures like images, okay, some simple data in like a series data. Series data RNN work better way, but series data, for series data also we use CNN for classification. But the problem in CNN, if you take it, one is long-term dependency problem and black box nature. I'll discuss about this black box nature. Just what I told, CNN is extracting features, patterns from DNA sequences, but we don't know which features it is extracting. It is giving 99.99 accuracy, but we don't know why it is, we got which features it considered, we don't know. That features we want to extract it. Sir, next slide. Yeah, this is one model we designed. So in this model, if you see the first part, one hat encoding vector. So the DNA sequence ACGT characters we converted into numerical vectors, one hat encoding vectors. If you see, they why 5 values are there means one more character exists in DNA sequence, that is N. Sometimes if you don't know what is AGCT, we will put N there. We will put N there. That's why we are converted into 5 length vector. We went for convolution 1D neural network. So this, it will extract and convolved filters will come after a group of convolution and pooling operations. Finally, we got there. If you see, flatten is there somewhere. Flatten is there. Before that, a small set of pillars or vectors we generated. Those are important features we extracted from DNA sequences. Okay. Up to this part, we can say feature extraction step. Next, if you see fully connected layers, and fully connected layers, it will do either classification or regression problems. Here we are doing classification problem. I represented it end layer two like pink boxes. Actually, one neuron is sufficient to do binary classification, but here I represented means two classes I represented like this. Now the question, how to, after repeating like multiple iterations, what we can say multiple epochs, okay, my model is trained. My model is trained means my kernels I can't show here. Kernel here, if you see first layer, kernel size, what is kernel size? 7 I specified, but the vector length is 5. 7 by 5 kernel automatically initialized, trained after training. The 7 by 5 kernel trained with or updated values. those kernels I am picking for explainability, those kernels I am picking. So these are the kernels, learned filters from convolution layer 1. First layer, I extracted those kernels. Those kernels are trained kernels. Means if you use these kernels, it will separate DNA sequence which have signals, DNA sequences which don't have signals. It will separate it. So the trained, I took again DNA sequences which have signals because I am interested which patterns are playing crucial role in the DNA sequences which have signals. Okay. So I took the same DNA sequences which have signals. So I applied again these by using these kernels on the top of these DNA sequences. We extracted feature maps. This is the feature maps represented in color. Feature maps means values, simple values. For each sequence, different values in row wise, we will get it. Okay. From that, I averaged those, for each sequence, I averaged the feature map values. That average I took as threshold. Okay. Threshold. And which in that sequence, in which positions the values, feature map values are greater than threshold, I picked it. Again, I went back those positions in this DNA sequence. Suppose here I got feature value is greater than threshold. Here I got, and so on. Those positions I pointed here in the DNA sequence. From that position up few characters, down few characters, I extracted. In that way, I extracted patterns. That extracted patterns, we got it. Huge number of patterns, we will get it. We calculated frequency of those patterns. Top patterns for each kernel, we extracted top 10 patterns. With that, we extracted pattern logo, we generated pattern logo, and those pattern logos are matching with the patterns which are stored already in the databases. So this is overall concept we should understand. So these top 10 patterns are the patterns extracted by the CNN. Okay, extracted by the CNN. So means by using those patterns only, it is classifying the DNA sequences into two categories. This is what explainability, or we can call it as interpretability. What we are doing, CNN is extracting some patterns as features. Those features, based on those features, it is dividing the signals or what we DNA sequences into two categories: true signal sites and false signal sites. So those patterns, what are those patterns means, by using this interpretability, we can extract those patterns. This is simple approach we applied. We extracted patterns. Okay, we extracted patterns. Now, how can we apply the same concept so to different research areas? You go for natural language processing. Okay, now you given reviews, right? We will write reviews for some products or some items, whatever you take it. How the companies will process the data, the same data, you take it to the, here took a DNA sequence and convert it into numerical vector. That same what we can say natural language processing data, review data, they will take it, each word to vec concept is there. By using that, they'll convert into numerical vector, they will process it. Okay, finally in explainability, they will identify due to which words. Okay, so what CNN took words, which words it picked, based on which words it is decided as it is a positive review, based on which word it is decided as a negative review. In that way we can apply. If you go for images, so suppose cancer images, non-cancer images, you take it. So which region of the cancer image it picked, based on which feature or based on which region it is deciding it is a cancer image, a non-cancer image. Like that we can do explainability. Nowadays so many videos we are seeing, by seeing our video, it is identifying objectives and drawing a bounding box, object detection. So how it is doing, due to this explainability only, which region that box is there and which features, which patterns. Okay, so image processing also we can apply. Any research area, signals, if you take it, which region the signal growth is every time high, that regions it will identify as features. Implicitly deep learning, whatever the method you take it, first it will work on numerical data. Directly we will not give me image or signal to any deep learning model. It will convert into numerical vector only. Based on the numerical vector, it is identifying important patterns as features. Important pattern as features. And in explainability, what we will do, what are those important patterns? What are those important patterns? In that way, the black box nature deep learning will unboxing. We are unboxing. This is a simple concept in neural networks, or we can say convolution neural networks. Just go to. Now come to deep, much complex concept is graph neural network. Neural network, where we can use this graph neural network. Why we are going for graph neural network? So if you take it CNN works for like fixed size structural data. But if you go for some networks, okay, networks where CNN will not extract features properly, okay, RNN also will not extract features properly. So many real-time problems we can convert like a graph, okay. So graph neural network extract proper structures from graphs. That's why nowadays, if you see, graph neural network is emerging a lot. If you see every 100 papers, 1 or 2 papers coming from graph neural networks. Okay. So now we targeted graph neural networks itself is very tough to train the model, but how to extract the patterns, what the GNN is extracting, that we want to extract it. So in GNN, CNN, RNNs works on structured data like images and text, but DL has opened to new world of possibilities for making predictions on non-structured data. Non-structured data like molecular structure, you take it. Molecular structure, how it looks like a graph, okay, like a graph. So how to extract pattern from the graph? Pattern means subgraphs, right? How to extract subgraphs from graphs? That is the task. So recently new class, that is GNN came. How GNN we can train it is, how can we represent graphs? Usually by using adjacency matrix or adjacency list, we can represent it. So GNN, how to extract features from GNN means, suppose you take nodes are there, graph nodes are there. For each node, if you take it any graph, different features we can extract for graph node, like rank of that, rank, what we can, degree of that node, and different features we can extract it. If you go for molecular graphs, molecules, atomicity, okay, charged, different features it came. So for each node in molecular graph is atom, one atom. For each atom, we can extract different features. We can manually, we will extract different features. And those features of each node, each graph is represented like adjacency matrix. And a degree of each node we can represent is degree matrix. And next we will use this degree matrix and adjacency matrix. Okay. How graph neural network will be trained is, suppose if you take any node, for that node, 5-6 adjacent nodes are there, just imagine. Okay. Each node have its feature at time instance t equal to 0. At level 0, all nodes have its own features, right? At level 1, how to train graph neural network is, at level 1, time t equal to 1 instance, whatever the adjacent nodes are there, those features we will take it. We will do aggregation, like aggregation means mean, median, whatever it is, we can take it. And we will add those aggregated feature values with the current node, particular node. And particular node also have feature set. Whatever the aggregated values we got it, again we will do aggregation with that node. At every node we will do this. This is level 1 training. Level 2, level 3, level 4. In that way we can train it. Finally it is trained. Finally the node features are updated and weights also updated. This is little complex to analyze. Okay, complex to analyze. At each node the feature values are updated. And weights are updated. Okay, weights are updated. So now I have a GNN network, trained GNN network. By using this trained GNN network, what we did, so just go to next slide. Yeah, GNNs we are using for drug discovery. So drug discovery, we assume that drug discovery is not part of computer scientists. Whose responsibility drug discovery? It's a part of biologists, pharmacologists, different people they are doing. In the lab they are identifying how they are doing trial and error only, right? They will trial on some rats or dogs, different on different animals they are doing trialing. Nowadays, for the business purpose, they are doing on humans also. We are seeing in many movies. But what is the role of computer science in this part? The part is we have one good thing is we have drugs for every disease, future diseases also. The problem is we have so many molecules, 10 power 60 molecules we have. Out of these 10 power 60 molecules, at least some molecules work for every drug, every disease. But how to identify those molecules? Which molecule for which drug? That is the challenge. Okay, out of 10 power 60, we can imagine what is 10 square or 10 power cube is 1000. 10 power 5, 10 power 60, imagine how big it is. Huge sample space is there. What is the role of computer scientist? Identify the relevant drugs within short time duration. That is our role. That is our role. So in COVID time, this is if newcomers, especially BTech students, usually BTech students think that research is not our headache, only doing programming and going for software job. Software job styles change nowadays. Job is dynamic. Every few years, job is changing. Who will do research paper? Like in BTech project, at least if you publish one conference paper with the support of your guide, that will give huge weightage for your resume. Okay, I'll strongly suggest in our campus also, we are forcing students to publish at least one conference paper. Okay, due to this, sir, I want to go for software job. Why this research paper? In software also you are doing the same thing, almost new things you are identifying, so you will get good research oriented job. Okay, research oriented companies also there, you will go and do high packages also there, research companies, right? Should I no one will select me in Amazon, it is possible, right? So BTech students also please do some simple research with the help of your guide, BTech guide, and publish simple conference paper. That is strongly suggestible, right? Now where we are, drug discovery. So out of these many molecules, what is molecule structure, how it look like? Just go to next. This is paracetamol. I hope you listen this name, paracetamol. Okay. How can we represent paracetamol? Just to see CC, opening parenthesis equals to 0. These are carbon, nitrogen, oxygen atoms only. Okay. We can represent like this drug. So now this is a string for me. For computer scientist, that is a drug, but it is a string for me. Okay, simple string. How can we handle strings? So many string handling functions are there. So I can convert this string into numerical vector. Numerical vector. So drug discovery is, here I have a protein, diseased protein. Diseased proteins, biologists or pharmacologists, they will identify 3D structure. Now I have a molecule. I need to impose this molecule on this top of this diseased protein. How effectively this chemical molecule is binding to this protein, that we can measure by using binding affinity score. So I need to identify quickly by using deep learning models which are the molecules are giving high binding affinity. Which are the molecules are giving high binding affinity. That is what drug target interaction. How drug means molecule is attaching to the protein or diseased protein. So we will do quickly that in computational point of view, we will identify a few hundreds of molecule which are best binding to the diseased protein. Those 100 or few number of molecules, they will test on the labs. Instead of doing 1 lakh samples on the lab, we are sending only 100 or 200 samples to test on the lab. How exponential time reduced to simple polynomial time. That's where computer science play a crucial role for in drug discovery. In drug discovery, it's like a every green every time wherever you take new diseases are coming, new drugs we can identify. This research is evergreen throughout your life. If you work, we can work it. So in real time problems also we will work it. At COVID time, COVID is this 2019 COVID is not new one. Previous 6 COVIDs are there, coronaviruses are there. This is 7th version of coronavirus. 1956 onwards, coronavirus is there. This is not a new one. So what we did is, those many coronaviruses are there. Why this 2019 coronavirus spread a lot? For that purpose, we identified one implicit that 2019 coronavirus translation rate is very high. Means the RNA is converting into protein very quickly. Okay, due to that, its impact is very high. Okay, its impact is very high. And another also there, only few regions its impact is very high, other regions it is not. Okay, so if you identify this protein, coronavirus protein, what we did, we trained, okay, generative adversarial neural networks. We identified only few molecules, we imposed on the top of this coronavirus protein, and we identified molecules, drug molecules, which work more better than remdesivir. Remdesivir binding affinity is less than what we identified. So these molecules we will give to pharmacologists, they will work on that on the lab. This is where this is what the drug discovery process. How can we do it? So this chemical molecule will represent like simplified molecular input line entry system, like SMILES, in that format. Sir, next slide please. So what is drug discovery is, this is a drug discovery, this coronavirus proteins, and that is our molecule, we can call it as ligand, drug, or chemical molecule, which will come and bind to this protein. What it will do, it will stop translation process. It will stop to convert the RNA into protein. It will stop that process. So RNA will not do any harm. If it converts into protein, it will do some task. We are indirectly stopping that process. Obviously, we are controlling the disease. Obviously, we are stopping that process due to this drug, due to this. Next slide, sir. Right. So this is chemical molecule structure, 3D protein structure, look like this. We are converting this protein structure into graph, and the chemical molecule into graph. Then we are applying graph neural networks to process this chemical molecule and to process this drug protein. After training the graph neural network, finally it will generate one vector, and after training this GNN on the top of target, it will also generate a numerical vector. Finally, we will merge those numerical vector. Later onwards, it's fully connected layer. We will find out, or here this problem we can formulate like a regression problem. Previous is classification problem. This is regression problem. What it will do, it will identify, it will predict continuous value. What value binding affinity it will identify. How this chemical molecule is binding to the target protein. Next slide, sir. So this is what I discussed here. We have chemical space 10 power 60, and this regression problem. The problem is, to train the model, we need binding affinity scores, chemical molecule, protein structure, and a score, binding affinity score we need. Such data sets is very less. With the given data set, what we trained, then for new proteins and new chemical molecules, we are identifying binding affinity. This is not our research problem. This is simple problem in research point of view. After that, how to extract the patterns from chemical molecules, which subportion is binding effectively to that, which subportion of the protein. This is graph, this is graph. Which graph or which some region of graph is binding which sub-region of protein graph. That we can say bipartite graph. How can we extract this subgraph from molecule? How can we extract this subgraph from protein? The protein subgraph we can call it as drug pockets, and the chemical molecule subgraphs we can call it as pharmacocores. Pharmacocores. By using trained GNN models, by using explainability, how can we extract pharmacocores? This is the research problem, right? So next. Here two problems are there. One is, first we train the model, we identified the drug candidates or molecules which are binding to the protein sequences that we can say drug candidates, chemical molecule whose binding affinity is very high, that we can call it as drug candidate. Identification of drug candidate, one problem. After identifying drug candidate, identification of substructure or subgraph from the molecular graph is another problem. So two problems we addressed here. One is, sir, next. Yeah, you see here, this is molecule converted into graph. This protein, here we didn't convert into graph, simple like embedding vector, one hat encoding vector, we did it. Then we passed to GNN model. Down one also we passed to GNN model, separate GNN models. It training happened. Finally, it generated GNN model, generated one aggregated vector, and the CNN also generated one aggregated vector. We combined those, and that we are giving to fully connected layers, and we are predicting binding affinity. So after doing training, we will send test set. For the test set, what is the average of binding affinities we took as threshold? Which molecules are giving above the such threshold, those chemical molecules we consider like drug candidates. Is the first one. Next, sir. Next one, after training that model, okay, DTI model, that the DTI model we are using, and drug candidates molecular graph, whatever the drug candidates we identified, that drug candidates and corresponding protein target, these three we are sending as inputs to the explainability model. We are sending to the explainability model. Here, in this, we are using MCTS, Monte Carlo tree search. What is Monte Carlo tree search? It's a heuristic approach. That Monte Carlo tree search, what it will do, it will prune the possible subgraphs. So now you take any graph, how many subgraphs possible? Huge number of subgraphs possible, countably infinite subgraphs possible. We want to reduce that. How to reduce it? Monte Carlo tree search is one such technique, heuristic searching technique. What we are doing, whatever the drug candidate, I consider like a root node. Then in that drug candidate, so each node degree I'm taking and arranging the nodes in the increasing order of their degrees. I'm deleting the node which have less degree. Obviously, it will separate the graph into different connected components. The connected component which have highest atoms, I'm considering as graph. I kept in one node. Next time, lowest degree. That we connections. Okay. Degree itself says right how many adjacent nodes are there. So what I'm doing, less degree. So I'm arranging the nodes in the increasing order of their degrees. Lowest degree node I'm deleting from that graph, like articulation point, what we will do. So after doing that, deleting that node, adjacent edges, it will form different connected components. The highest atoms connected component I am picking. Is there any threshold value? No threshold. So I'm calculating number of atoms present in the connected components. Which connected component have highest number of atoms? That I'm picking. I'm considering like one subgraph for that root node. Same way, I'll repeat this process for finite number of times. Like there is a hyperparameter for like 14 in the literature, it is there 14 nodes we generated. And in Monte Carlo, after generating this, which node we need to exploit? Exploration, we call it MCTS. There are two terms, exploration and exploitation. Exploration is for one node, how many children it is generating, that is exploration. Out of generated nodes, which one we have to, in which path we want to move, that is exploitation. To do exploitation, what we are doing, each subgraph I'm sending to the trained model along with the protein. How this subgraph is binding to this protein. Okay, again binding affinity we calculated. By using binding affinity, and the actual threshold ground truth, we generated error. By using this error, probability density we are calculating. By using that probability density, we are using as reward score in MCTS. The which node have highest reward score? So by using reward score, we will calculate UCB, upper confidential bound. For which node upper confidential bound is very high, that node we can exploit it. This process will continue until each subgraph contains at least 3 nodes. So in this way, we are pruning the tree. Suppose now the tree is expanded. I got 100 nodes. 100 nodes means 100 subgraphs. For which subgraph the reward score is very high, that I am picking finally. That subgraph is the feature extracted by GNN. That subgraph is no, actually it is continuous value. It will start from 0.5, 0.7 to 12, 9, like that. That's why threshold how we picked based on testing molecules. 100 test molecules are there. We extracted binding affinities. Suppose one, its range is different, right? So then we took average of that, we set threshold. Above that average, above that, suppose I picked as I selected average as 6. Above 6, whatever the molecules giving binding affinity, those I consider like drug molecules because it is binding effectively, right? Comparatively. So in this way, we can identify drug candidates, and inside a drug candidates, we will identify subgraphs, that is pharmacocores. Actual pharmacologists require this pharmacocores. So this is where real-time research works, right? So this pharmacocores, we identify this is pharmacocore. This subgraph is pharmacocore. How we are formulating biological problem into computer science problem? Yeah, next, sir. Yeah, these are some experimental results. Good. Yeah, wait, sir. So this is the, see, you see the molecule, middle one you take it. Middle one is the drug candidate. The nodes are atoms, edges are their links, whatever we can call. Beside one, if you see, there is a small graph, molecular subgraph, and that molecular subgraph represented in red color in the original graph. So GNN extracting that region as feature, and based on that, it is deciding this molecule is a drug molecule. Okay, this is where explainability we can call it as. Next, sir. These are some results. Finally, come to conclusions. Right, GNN nowadays in drug discovery process, GNN is playing very crucial role. To understand GNN, we have to put sufficient amount of time. I think I tried for 1 month to understand GNNs, how it will learn, how it will train. CNN is simple, just like if you know some of products in digital electronics, SOP, right? Some of products, we can understand CNN. But GNN is much complex because it will take adjacency matrix, multiplications, aggregations. Two things are there. One is message passing from adjacent nodes, aggregation of those values. After that, how GNN is extracting patterns is explainability that we have to work out. If you are strong in coding, you can do it, but you have to spend some time. That is required. Now, what are the future problems? Suppose if you design a model, one thing is we can design graph neural generative adversarial network models to generate novel molecules. Once you train the model, you train it. Now new disease came. For that new disease, you can just pick some molecules by using this GAN model. Those molecules you test on the new disease. You test on the new disease and identify finite samples, and we will pass to pharmacologists. They will test on the labs. Okay, and this is the research. Next one is extracting binding protein packets. Now we see which region of molecule is binding to protein we identified, but which region it is attaching we didn't identify. That is open problem now. Now after that, which bipartite graph plays crucial role in drug discovery, that also we can identify. So these are future open problems. So if you are interested, you work on bioinformatics, and strongly suggested the new beginners who want to start research. This is a good open area where you can work. In India, we can count only few people are working in bioinformatics. Okay, not even all IITs, only few, 4 or 5 people are working. All NITs, only 4 or 5 people are working. So hardly 20-30 people working in bioinformatics in India. There is a huge scope to work in this research area. Okay, so so many open problems are there. Like we are working, like see, corona spreaded in different regions in differently. We want to find mutations in this region, why it is spread a lot, what are the mutations it happened in DNA sequences. So which region, which mutations are happening, different types of mutations are there in different regions. We want to extract those regions, right? So like this, I'll stop here. I'll open for questions.
Each protein will have its own DNA sequence.
Each protein is generated from DNA sequence. Okay, what is protein from DNA? It is evolved. In between, the other RNA molecules, like viral molecule RNA came and attached with our RNA. It will spoil our RNA. Due to that, wrong protein will generate. Okay, so in coronavirus, they will collect samples from different deceased persons DNA, and they will identify 3D structure of coronavirus protein structure. That is 3CL pro protein structure is coronavirus protein structure. On the top of that protein, we will not work on multiple proteins, only single protein will collect it. So for computer science to identify drug candidates, first we need protein structure. Once the biologist will give us this is the 3D protein structure of particular disease, on the top we will work. On the top we will work.
Directly we cannot find the protein structure.
We see it's possible, but a lot of biological process is involved in identifying protein structure. Computational wise we are doing protein structure, but still a biological involvement is required to identify 3D protein structure.
In many of the medical fields, the data won't be available.
Yes, that is the biggest problem for us. Yeah,
So that means
mimic data set.
Is there any information about that?
Sir, actually, we are focusing more on gene based. We have so many open databases. Like if you go for coronavirus, GISAID data set they generated, GISAID, GISAID. But only they will give permission for few people. They'll not give permission to students to access that. So as a faculty, if you request them, they will process your profile. Really this fellow wants this data or not, and they will put some restrictions. We are working on that data. And NCBI, okay, uh, National Center for Biotechnology,
They're asking you writing the exam from cases.
sometimes, sir, but that NCBI we will get data. And we are also working on neurological disorders. Nowadays society is facing another big issue is neurological problems, psychological problems. Okay, psychology, neurology, little difference is there, but most of the people, even young people, are facing psychiatric problems, like due to stress, due to other reasons. And these addiction also one type of psychological disorder. Most of our students, we can see, they are addicted for mobiles, right? How many are addicted? So many people are still using mobile phones. Everybody is addicted. This is the biggest problem in future. Okay, what is the problem in next generation is how to separate a mobile from, we need to identify some software. Okay, we will send alarms to the parents, your kid is using 13 hours okay, mobile in a day. So this is the biggest problem. Only thing, we have to motivate our students. There is no other option. Every day in my class, at least 5 minutes I'll take to control this. And we will take very serious action. If we identify any mobile, we will fine 15,000 directly to the student. So this is the thing we will see. We will smoothly tell, because As a human being, we will not listen. If you face problem, then only we listen, right? So we need to save our next generation. Only option is some actions we have to take.
What in the graph neural networks where we can get the
Best there is a tutorial classes, sir. ML for graphs, Stanford University. 64 video lectures are there. So first they only introduced graph neural networks. Okay, ML for graphs. They took good lectures are there, but before that we need to go through that at least deep learning course applied AI that ISC Bangalore people introduced. So if you go through that, then only we'll understand this ML for graphs. At least few topics, a few lectures we can understand. But GNN, before going to GNN, we should understand ANN, then convolution neural networks, whatever the activation functions are there, whatever the optimization functions are there, all probabilistic approaches we should understand. Then only we'll understand those lectures. Otherwise, a little difficult. Recently, this explainability, if you search it, only 200 to 300 papers only released till now. That those are also from like few papers from Stanford University, few papers from Cambridge University. But there is a huge future next 5-6 years. This explainable AI. Now explainable AI is that word we are using, right? Explainable AI tools in machine learning, deep learning. So next 5 years it will rule the world. Okay, so there is a huge scope in this direction. Any questions from student side? Anyone is interested to work? So most of the BTech students do ML projects, but you people use pre-existing code, GitHub codes, all these things. The best thing is you try to develop your own code. Don't use existing packages. Okay, so that's it. Any questions? Then I'll conclude here. Thank you very much for your patience.
That was very informative. Now let us have a break for lunch. Sharply at 1:50, please I request everyone to assemble here. And for students, lunch is at
PPT, please handle because content will be published. Your name?
any offline presentation.
You only, right? KUPH.
Presentation.
Good chase.
కంటిన్యూ మా 1 year అయిపోయింది
అదే యాక్చువల్గా అది
డిలీట్ చేస్తాను
దాంట్లోకి
ఇప్పుడు సెకండ్ ఇయర్ నడుస్తుంది సార్ ఫస్ట్ ఇయర్
అయిపోయింది. మొత్తానికి స్ట్రగుల్స్ లో చేస్తున్నాం. కంప్లీట్ చేయండి.
వీక్లీ 3 days అటు 3 days ఇటు
అవునా?
థ్యాంక్ యూ సార్
Guys, if there are any offline presentations, be ready with your presentations and after this, whoever have not filled the form yet, please go fill it outside. Now we have an offline presentation from Sir Jasinder Kumar, and the research paper title is Advancing Thyroid Nodule Evaluation with Deep Learning and Ultrasound Imaging. His paper ID is 214. I invite you, sir.
Yeah, good afternoon, everyone. I am Jatinder Kumar, and I am working in the IT department of Icaaiml Chandigarh, which is one of the premier institute in the medical education and research. Basically, we are working in the live project in our institutes. We are using HIS, that is hospital information systems, and the topic is advancing thyroid nodule evaluation with deep learning and ultrasound images. Next. This is my outline of my presentation: introduction, literature review, object, deep learning architecture, data flow of the proposed system, materials and method used, image processing, proposed methodology for image enhancement, result analysis and discussion, conclusion and references. Let's go to the next slide. Yeah, thyroid. Thyroid is a gland which is situated in front of neck and produces two vital hormones, that is T3 and T4. And 90% of the hormones which is produced by the thyroid glands are responsible by the T4, and only 10% is responsible for by T3. The This is a whenever any patient visit to the specifically pediatric thyroid department, the doctors, even if the patient is new or the older one, they recommend ultrasound for the examinations for detection of the disease, as well as to rule out the progressions and medication purpose. And the my topic is to classified the thyroid images, which are the malignant one or benign one, that is cancerous one or non-cancerous ones. Even thyroid is a lifestyle diseases, and it hinders the development of the kids, mental, physical, their sexual developments are depend upon the thyroid glands. It If it detected at the earliest stage, it can be treated and fully curable in the specifically in the pediatric populations. And thyroid diseases are classified mainly in four categories: hyper, structural abnormality, tumors. Hypo, when there is a lack of thyroid hormones in the bodies produced by thyroid glands. Hyper, when there are lot of and these are the symptoms: fatigue, weakness, weight gain, gold, and all these are the symptoms of thyroid disease. Hypothyroid, when there is a lack of, there are very less hormones produced by the thyroid glands, it is called as a hypothyroidism. Structure of normality, short structures and large structures, bodies, tumors, maybe the thyroid nodules is a cancerous or non-cancerous, and other subclinical hypo or hypothyroidism, abnormal thyroid function test without any clinical symptoms, when they don't find any clinical symptoms, and but the signal go that it is suffering from the thyroid related issue, it is called as a subclinic hypo or hypothyroidism. Go to the next. Right. So coming to the biomedical images, basically I am working only with the ultrasound images. It is also known as ultrasonography or sonography. Clinical photographs, when skin department or others diseases they take. Scintigraphy, it is a nuclear medical test. X-ray, CT, magnetic and all. But my research work is only related with the ultrasound images. It is also known as ultrasonography, or sometimes also written as a sonography only. And in short, USG written for the ultrasonography. right? Features of thyroid nodules. What features the radiodiagnosis people look into the thyroid image? These are the nodule size, its composition, its ecogensity, and margins, and shapes and vascularity. Whenever thyroid image go to the given to the radiodiagnosis, these are the features on which he try to find out the which disease this patient is suffering on, right? And thyroid imaging and reporting system. Thyroids is a commonly known. This is used to rate thyroid का score rate to find out the thyroid score. If the thyroid score is 1, it is treated as a normal thyroid, and if thyroid is 2, it is benign condition, 0% malignancy case. And this is a standardized practice which the radiodiagnosis peoples are used to rule out. And if the score is given 1, it is a normal thyroid, and 2, 3, 4, and if the thyroid score is 6, then they recommend for the biopsy. A piece can be taken and given to the histo or cytopathology department for find out the what kind of cancer is there. Next. And my work, I review the lot of literatures to come out with this model, which I am going to be discuss. Existing work related to the thyroid, I have explored existing work in the object detection and segmentations. Then performance matrices. What are the various performance parameters which we can use to find whether our model is suitable or not? And feature, yeah, this is a little. You can skip this. Yeah, skip this. Next. Yeah, my objective is this. I propose a system employing using the deep learning models, namely ResNet 18 and BGG 19, Visual Graphic Geometry Group, right? So I took on the basis of with the MATLAB 202B and with the publicly database which is available DDTTI datasets. I use this dataset and compare the performance of ResNet 18 and BGG 19. Right, next. So whenever we talk about the deep learning architectural implementations methodology, we need to first define the problems and a collection of data, model selections, data pre-processing, model building, training. Earlier speakers have a lot of spoken about the training and testing, regularizations, hyperparameter tuning, that how much epoch and times comparisons are during these hyperparameters taken, model evaluation and deployment, monitoring and maintenance, scalability, ethical and regulatory consideration, documentations, and knowledge sharing and collaborations. These are the steps. So implementation methodology में when we can develop our own deep learning models, or we can use the pre-trained models, or we can also another methodology we extract the features from the existing databases and use those features for our models. Next. Yeah, this is the data flow diagram. I took the thyroid images, then pre-process these images, but the images for the any deep learning or machine learning, lot of data is required. Otherwise, the results are supposed to be biased. And I did the augmentations of the images, then use the ResNet classification on the basis of and classified as a benign or malignant. I'm coming on that. I'm coming on. Yeah, next slide. So this is the data. The data set which is images of size is 560 and 36 by 6, and 427 thyroid images has been used from the 299 patients, and among these 357 are malignant and 72 are 70 are benign. These are negatives, and score are also mentioned here. Next. And after augmentations, I augmented 427 images to 2000 images, and 427 are original and 5 1573 are the augmenteds, are included in the final database. Right? These were separated into the test for training, testing, and validations. Right? For training, 1,000 images were taken, testing 500, and the the images 500 and 500 are not taken part in during the training part, and which are taken in the test page are not for the validation purpose. These are the separate images. Right? Come to the next. These are the options which I have used for augmenting the training and all the image rotation, image flipping. On next, please. So, image pre-processing, all the images are of different sizes. First, I use the function which is IM resize of MATLAB to resize all the images to equal size. And these are also noise prone images because these are quite old images. And these are the filters, binary filter and median filters. Performance of after the first input image, this is the median filter interval, and C1 is the binary filter, the output image. Yeah, coming. Yeah, yeah. Go to the next. Yeah. So these are the image enhance functions I have used for enhancing the quality of the images. Next. Yeah, proposed method is this is the proposed method which I have used for the image enhancement and noise removals. Come to the next slides. Deep learning neural. Come to next. Yeah, this is the architecture of 18, Resonate 18, which I have used. Next, and this is the architecture of ECC 19. Next. Yeah, this is the result and discussions. This is the validation progresses of ResNet 18, and this is the batch loss. Figure 12 is representing the batch loss during training periods. Next, and result analysis and discussions. Validation accuracy come out 97.13 in case of ResNet 18s, and this is the APOX 15s, and number of times has been taken and how much number of images have been taken during the validation process. Next, please. And this is for the BGG 19 result. Next. This is and the validation accuracy as compared to the Resonate 18, it is just giving me the 90.31%, and the APOX and having the same for both the images, right? And I have tried to compare the accuracy of BGG 90 and Resonate 18. Next. So this is the interface which the user will get. Actually, I am working in the PGI, and my co-guide is Professor Devidal, who is the head of the pedagogic units. When we use this model with the actual images, it is almost 99.5% because these images are quite old and not taken with the very good. These days, the ultrasound images are very good and they have very good resolutions. And we already started testing with the actual data in PGI. Whenever the patient's visits, ultrasound images taken, the other parameter, their blood test result as well as the ultrasound images comparison, and they are trying to implement in the PGI. And this is the result. Upload an image, it giving me the result whether this image is benign. And next, and if another image can be taken, it is giving me the message malignant. Next. So conclusion is this: because in India, if any public hospital, whenever we get a lot of rush of the patient, the ratio between the doctors and the patients is very high. Yeah, so it's for a patients who, if it is diagnosed very early and technology can be deployed, it is very useful. And I think with these kind of model, which we if we can implement in a public hospitals, no patient can be left without diagnosing properly whether the nodule he have a thyroid is malignancy or benign cases. Next. 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 These are the references which I have used. Next. 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 Yeah. Any questions?
So what is the activation function used in Resonate 16?
Yeah.
What is the activation function used?
Yeah, I need to check it. We check it. Yeah, optimal. Yeah, originated. Yeah, both are same. Thank you so much. The pen drive.
Charging.
I will be reading the manuscript IDs. If anyone is present here, please raise your hand. 120, 138, 142, 198, 210, 214, 219, 223, 224, 238, 239, 240, 276, 347, 178, 350, 309.
Srinivas and Srinivas. 23 and 24. 23 first, 20. Good afternoon to all. Myself, Vadali Srinivas. Today I'm standing before you all to give the presentation on my work. It is related to the uh, developing predictive models for wildfires by utilizing a novel dataset of advanced machine learning techniques. So, which is very crucial. The forests are having the fire accidents, and with this particular machine learning model, we can able to predict. Uh, please next. So the importance for the wildfire reduction is the first one is environment impact, because we have to protect our environment by saving the forest. If there is a fire occurs, the impact will be very high. The ecosystem will be damaged, and here we are having so many challenges. We can eradicate, we can control it by predicting well in advance. And here in this machine learning approach, the important concept and the oxygen for the machine learning is data. The analysis of the data is very crucial, and data driven solutions and ecological data. So here we have considered huge amount of data. I'm going to discuss that one. Next slide, please. So the main motto of my research work is there are some research gaps which I found in the literature reviews here and statistical models. So previously some work has been happened on the based on the statistical models uh, and machine learning advancements. So when the huge data is increasing day by day, there is lot of advancements are happening in the uh, machine learning techniques, all because of the generations of the huge the uh, implicit increase of the growth of the data is happening. And here the deep learning techniques used are previously recurrent neural networks, convolutional neural networks. And here we performed the integration of remote sensing. And the methodology data set construction is data acquisition, data pre-processing, and data conversion and clipping. As data pre-processing means we will consider the data which is required for us, and also we will remove the noises, missing data in the data pre-processing. Here we have used the data pre-processing techniques. Next slide, please. And the methodology for our the workflow of the research is in this way. First one is data extraction. In that we concisely consider the parameter extraction. Next we have applied the data mining algorithms for performing this data extraction. And here we have used the support vector missions. Next. So here we got the results when we applied the neural network support vector mission. So I'm unable to show the slide properly due to some versions of the Microsoft. I couldn't show the results properly, but here you can see the result with help of support vector missions, how we achieved almost and also we have used the k-fold cross validation, and the result is 99% accuracy. I welcome you if you have any questions. Thank you. Sir, next one. సరే ఎవరైనా చెప్పిన తర్వాత నేను చెప్తాను. నెక్స్ట్ కూడా నాదే, కానీ ఎవరైనా చెప్పిన తర్వాత చెప్తాను.
Now I invite P. Kiran Kumar sir. The research title is Classification Model for Benign and Malignant Tumor Cases in Brain Tumor and Lung Cancer. P. Kiran Kumar sir.
I am P. Kiran Kumar, research scholar from Kakatiya University. My paper is Convolutional Neural Networks Modeling Benign and Malignant Tumor Classification. Introduction. మాది వేరే సార్ ఉంది కానీ మాది వేరే సార్ నాది సిఎన్ఎన్ సార్ మాది వేరే సార్ Tumors are abnormal growth in tissues. Types of tumors are two types. One is benign and other is malignant tumors. Benign tumors are less urgent and malignant tumors are more. For therapy purpose, we use the MRI data and CT scan data. By using this we divided which tumor is benign or malignant. By classification only we can treat the tumor. CNN models like ResNet, VGG and inspection may be efficiently taught for tasks related to medical picture categorization. DCNet hierarchical learning framework used to learn complicated data of 95.03 accuracy. These are results of artificial intelligence and deep learning based automated cancer detection systems. This data contains the images of normal brain and pituitary gland and glioma. Every single picture was captured. Next conclusion. Thank you.
Okay.
Three zero
309. Kiran Kumar. Username password.
Which directly the medical activity.
Media. Black difference. 223. Last ID 224. वो लड़का का मेरे आई नहीं है
Now I again invite Srinivas sir, paper ID 224, research paper title, Real-time object recognition using deep learning with TensorFlow.
Good afternoon to all. Here, another my research work is real-time object recognition using deep learning with TensorFlow. As the title implies, so the research work is happened on the uh, of, real-time object recognition and how the TensorFlow is used for performing the real-time object detection is the major application of my research work. And here, uh, deep learning has been used to action detection, labeling of the data, object tracking, picture categorization in the recent years. And here, the TensorFlow is used for the better results. So the research flow, the presentation consists of the machine learning technique, representation learning, convolutional architecture, and FAR 10 data set. And that particular data set is divided into 5 batches, and common things every day we will see in the life. And the main motto of this real-time object detection by using the TensorFlow is we have performed the literature review for the last couple of years, and based on that particular research, we found some gaps and we fulfilled those gaps in our work. So the efficiency is one problem we identified in the research article published in the 2012. And the efficient net, another important aspect is the efficiency was not up to the mark. And next one is faster RCNN and SqueezeNet. SqueezeNet is one of the important deep learning techniques which has been used, and we continued the work which is happened in the year 2016. Next slide, please. And here, the methodology is, first of all, we concentrated on the convolutional layer, and next we concentrated on the pooling layer and fully convolutional layer. Here in the architecture, sequential convolution layers, in the sequential convolution layers we have used the filters of length 64, 128, 256 for the image processing and the recognition by using the TensorFlow. And the next one is hyperparameters and cost function and optimizer. So here, how quickly we can give the result that can be identified with help of the cost function. And also we have used the optimized techniques for the better results and proper recognition of that particular image. Next slide. And this is the work which I have done. Any doubts? Sir, I will show you. Sir, pen drive is in.
The session for offline registrations are over, then the online presentations are conducted and the respected people have their links. And I thank everyone who has presented here. It was a great pleasure and the event was successful. Thank you everyone. And students from other colleges, anyone? No, okay. See, there anyone, they'll be provided with lunch in 203, which is present in first floor. And others are requested to book for lunch, which is conducted in the orientation center. Thank you.
Sir, mic answer.
సార్ సారీ బ్యాక్ అప్ అన్నాము అంటే మంచి వాళ్ళే సార్ సార్
చౌదరి సార్ రూమ్లో ఉండాలి అంటే దాని కింద ఐఓటీ లేకపోతే ఉన్నాయి కార్డు మరి పనిచేస్తుంది ఐఓటీ ల్యాబ్ చౌదరి సార్ లేకపోతే నాగపూర్ సార్ దగ్గర
స్టూడెంట్స్ వస్తున్నారు కలిసి సార్ ఏం చేస్తుంది కొంతమంది ఆఫ్లైన్ వస్తారు పెట్టుకున్నాం రమ్మను నీ అవ్వడదు నీకు నాలుగు అయితే నీ 30 17 17 కదా ఎంతో కోటి 8 మినిట్స్ షెడ్యూల్ ఇచ్చింది 8 మినిట్స్ మీ పిల్లలు కూడా మరి సార్ మీరు కాల్ చేసుకుంటారా ఓకే మళ్ళీ 2 o'clock 10 కాల్ చేసుకొని సార్ 1:30 మళ్ళీ ఉండాలి
పని చేద్దామంటే పని చేసేద్దాం, ఇదేమన్నా డైరెక్ట్ పని చేస్తాం. తాళం ఉంటేనే కదా తాళమే దానికే ఉంటుంది. అంటే ఏ డిపార్ట్మెంట్లో వీడియో పెడతాం సార్.
ఏమైనా కొడుతున్నారు
తగిలింది కుదురుకుని నెట్టిపోయి చేసినప్పుడు పరిగెత్తాల్సి వచ్చింది.
లేకపోతే మీరేం తగిలించుకున్నారు కదా
స్టెప్స్ దగ్గర తగిలింది.
మీకు మళ్ళీ మెయిల్ పెట్టాను, అది అదే ఓపెన్ చేయండి.
అదే టూ పెట్టారు కదా,
టూ
టూనే పెట్టారు.
తీసేయండి, నేను మళ్ళీ వస్తాను. అయిపోతేమో పని మీరు అసలు ఏం అడగరా తీసుకున్నారు ఎవరు ఎవరు అది కూడా
ఇదిగే సార్, అదే పక్కన ఇది లైవ్.
చెప్తాం తర్వాత చెప్తాం. మంచిగా వస్తుందా?
నెక్స్ట్ ఫోటోస్
ఏమవుతుంది? అనిమేషన్స్ అలౌడ్ అన్నాడా, నాట్ అలౌడ్ అన్నాడా?
నాకేం తెలుసు, దాని ప్రకారం నేను పట్టించుకోవడం లేదు. మనం చెప్పింది అంటే 12-13
నేను 21 పెట్టినా, అందరికంటే ఎక్కువ నాదే ఉంటుంది. మంచిగా ఫోన్ చేయలేదు, ఏం లేదు,
ఫోన్ చేసి కలిసారి ఇవ్వలేదు.
పెట్టండి సార్, మీరు ఇప్పుడే రెడీ చేసి పెట్టండి. ఏముంది? ఆ బుక్స్ ఉన్నాయా సార్ ఇక్కడ?
నెక్స్ట్ ఉన్నాయండి ఇంకా సార్ ఉంది, స్టూడెంట్స్ వస్తున్నాడు బయట నుంచి.
హెచ్ఓడి సార్ ఇన్స్టిట్యూట్
ఆగి ఒకసారి
లైవ్ స్ట్రీమ్
లైవ్ స్ట్రీమ్ క్లోజ్ చేయమన్నా.
ఆగండి నా పనికి ఒకసారి చేసి మళ్ళీ అప్పుడు స్టార్ట్ చేద్దాం, మళ్ళీ పెట్టొచ్చా?
నేను ఎందుకు ఇన్స్ట్రక్షన్స్ ఇస్తున్నాను?
So keynotes అయిపోయింది. No sir, no sir.
Why you are using instructions? Oh, sorry, I forgot that he's
కోఆర్డినేటర్.
ఇప్పుడు మాట్లాడొచ్చా? ఈయన